Hi, this is Sky Sweeney. I realized that in the last video I made on the intro to my SUNDAR, I really didn't have a good close-up of the radar head here. Actually, not so much radar, but SUNDAR head. Thought I would give you a little closer view of what's going on. So here it is zoomed out. It's on the order of 3 inches by let's see, it's about 2 inches deep on the plywood. This is like 1/8 inch aircraft grade or model airplane plywood. The NEMA motor under here is bolted to the bottom of it. The shaft comes through and goes into a metal collar which is under here, which this screw goes into. That collar is about 1/4 of an inch thick. Just happens to be just about exactly the right thickness for these 3 strands of ribbon cable. And on the bottom of that metal collar is another piece of plywood, so this is like a spool. We'll get a better view of that in a minute. On the circular part here, there's a little tab that I've left. That tab engages this optical brake sensor, so that I can position it and zero it at the during calibration at the very beginning. The sensor is mounted back here in this piece here, which is made out of balsa wood to keep the weight really down low. This is pressed fit in, but I have a little bit of blue tape holding it in place right now. In the final version, this would be molded out of plastic or 3D printed out of plastic, and the wires, rather than going to this monster header, would be soldered directly in. So I'm going to put this little bit of tape back in place, get that out of the way. The business end here is a slit, and that slit looks right down into the sensor, but it doesn't have to look at the sensor directly on. It has maybe 20 degrees up and down off center that it can be, and that was intentional because as the sun sets and rises, I didn't want to have to be changing it at a very fine increment. My first implementation was a tube instead of this slit, and there it had to be dead on for it to work. In this case, it does not have to be dead on. So let's see, the 3 wires coming off of the sensor come down into this hole and then go down into the spool below, and we're going to look at that in a second. So here we are now looking dead onto the side of the head. This is 1/16 of an inch plywood, and there's another 1/16 of an inch piece of plywood at the bottom, and this is the ribbon cable that's wrapped around that metal piece that clamps the motor shaft, clamps to the motor shaft. So I'm able to screw into the top of it, into the bottom. And that part is available at Pololu. It's a little toroid about 1/4 of an inch thick, made out of aluminum. And screws into the top, screws into the bottom, and allows you to connect devices to the shaft of the motor. Off to the side here I have this little paper clip bent with a loop. That's a guide for the ribbon cable coming in. Very simple. This was just a sloppy copy here, it's a rough draft to get going to make sure this works. Currently I have no method of holding this in place to match the sun. I really have to jam something underneath it, but I haven't even thought it through, because if I raise this up too much, the header comes down and then interferes with the optical brake sensor. So I am in the process of redesigning this head to try to make it smaller and less mass, so that I can spin it at a faster rate. So there are some more details. Thank you very much.